Hi guys, today we're going to have a look at how we can answer questions like this when we're dividing a number by a decimal. So the first thing I like to do is write it as a fraction. So instead of writing the divide sign like this, it's definitely easier doing it like this. Now the whole way through this, I want you to think about fractions, especially easy ones like this. Now you should be very happy saying, well, that is the same as a half. And so is this, and so is this. And you can see, just change colour, that this one I've times by 2 to get there. I've times this whole fraction by 3, and I've times this whole fraction by 7 to get to this stage. Now these are all equal to a half, so whatever I times something by, I don't need to change it, I don't need to do anything else, because this answer, and this one is still a half. So I can change this question here, 38 divided by 0.1, to something a little bit easier to work with. Now, what you need to start thinking about is, how can I remove this? So you need to use the easiest mathematics that we know, and that's timesing by powers of 10. So watch what happens if I times this by 10. So I have 38 times 10, which would be 380. And I have 0.1 times 10, which is 1. So that means the answer to this is 380. It's as simple as that. Let's try a different one. Let's do 54. We're going to put it divided by 0.01. So I'm going to write it as a fraction. Now, on this one above here, we times it by 10 because there was only one decimal place we needed to move. Here there's actually 2. So times it by 10 will actually only move it to here and just be as complicated as the first one. So if we times it by 100 this time, we'll get 5,400 and 1, which therefore means it equals 5,400. Now you might even be able to see a pattern between this type of question and the answer. But I'm going to just go and look at some different examples. Let's make it a tiny bit harder. So let's take the example 24 divided by 0.2. So write it as the fraction. Think about how we're going to remove this part, just so it's 2. That's times it by 10. So make it 10 times bigger. So it's 240 divided by 2 this time, which therefore is 120. And we can do the same. Let's do 38 divided by 0.02. Write it as a fraction. I'm going to have to times it by 100 this time to get rid of the decimal. So that's going to give me 3,802. Now if you struggle to do this, then just look at the non-zeros. So what's 38 halved? Well, that's 19. So 3,800 halved would be 1,900. And we can make it harder still. So let's look at this one. Let's do 36 divided by 0.12. So that's a really nasty looking number. So write it as a fraction. How can I remove this decimal so it's just 12? Well, times it by 100, of course. So times it by 100. That's 3,600 over 12. Now, 12's going to 36. 1 12 is 12, and 3 12s are 36. So therefore the answer is 300. 300 over 1 if you like, which therefore is 300. Okay, so you might have got the gist of it now. So sometimes what we'll have is we'll have a decimal as well here. So let's try this one. So let's do 48 divided by 0.6. Write it as the fraction. Let's worry about removing this one on the bottom. So with times this by 10, we will get 48 over 6 and therefore that is 8. Let's try something a little bit more complicated. So let's try 0.72 divided by 0.6. And you'll see that doesn't look very nice, does it? So if we set it up like this, if we only worry about this part, we've got times it by 10. So that would give me 7.2 divided by 6. Now you may not like this. If I told you the answer is 1.2, you might be able to see a pattern already. But what you can do is times this by 10 again, so you get 72 over 60. Now you can go through the process of simplifying fractions. You should see that 6 is in both of them, so 6 is going to that 10 and 12. So it's 12 divided by 10 and get 1.2. You can think of it like this. You can think of it as, well, 6 is into 72, but that would be 12. But this isn't 72. I've got to divide 72 by 10, so I have to divide my answer 12 by 10. Either way, whether you go this way or just straight to the answer, it is possible. Now, potentially this may be the hardest question of all. So if we have 20 and we divide it by let's go 0.06. Okay, so we're going to have to times this by 100. Oops, there you go. So that's 2,000 divided by 6. Actually, this isn't what I was thinking about. But because 6's don't go into 2,000, you're going to need to set up some sort of division. So I think the easiest way is to say, how many 6's go into 2? Well, because they don't go, we then combine these two numbers. So how many 6's go into 20? Well, that would be 3, because 3 6's are 18. So it doesn't fit exactly into 20. We have 2 remainder. So that remainder goes there. So how many 6's go into 20 now? And well, that would be 3 as well, because it's the same question. And we'd have a remainder of 2. So how many 6's go into 20? Well, of course, that's again 3. And what would happen is we'd keep getting this remainder carrying over. It would go on and on and on and on. So the answer to this one is 333.3 recurring. But normally we give you some nicer numbers than that. So let's finish off with one last really tough question. So let's try this one. Let's try 52.12. So a horrible looking number divided by an equally horrible number. So write it as a fraction. So let's go for this. So we're going to have to times it by 100 to get rid of this one. So we times it by 100. That would give me 5,212 over 16. Now, this isn't particularly nice because I don't know my 16 times table that well. Certainly not to this sort of level to see if it goes in exactly. So I'm going to have to set up a short division. So 6 is into 5, they don't go. So let's combine these two numbers. Well, 16 is into 52. Now, a lot of people now go, well, I don't know my 16 times table. How am I meant to do this? Well, it's very simple. You write 16, then you add another 16, then you add another 16, and sooner or later you have your 16 times table. So I'll stop there because 48 is near 52. So I know there's 3 of those, and because that's 48, I'd have 4 left over. So let's put our remainder of 4. And again, I can see here I don't need to do any more 16 times table. So 2 16s are 32. So it's going to be 2 of those, and then I would have 7 remaining. So no, I wouldn't. I'd have, what am I saying? I'd have 9 remaining. So now 16's going to 92. Let's work this one out. So let's add another 16. So if I add on 6 to this, I get 54, so that's 64. And then I get to 80, and then I get to 96. So we're looking for this one here. So 1, 2, 3, 4, 5. So that's 16 fives at 80. We'd have a remainder of 12. So we add our 0, and we have to keep going. So let's add 16 on again. So it's 102, 112. So here we go. So 5, 6, 7. We'd have 8 remainder this time. So the difference between 112 and 120 is 8. So I've got a feeling this one's good. Oh no, here we go. We've got the end. So 16 times 5 is 80. So this is the most sort of horrendous answer you are likely to get. I doubt anything is going to be this hard. It's just because I'm making them up as I go along. So hopefully you followed that. Even with horrendous sums, a bit of short division, carrying over the remainders, being patient with your times tables, you'll get the answer. Okay, good luck guys.